Observatories in the early times used to measure the values of the field on an hourly basis, and now they have, with improvements in magnetometers, with automatization of measurements, now most observatories measure the changes in the field at every minute or even every second. So observatories are able to monitor the changes of the geomagnetic field over tens of years, to now there are observatories which have measurements over a couple of centuries. So these measure the secular variations. Now we have also decadal and solar cycle variations. We have the 27-day variations, and now we are also able to see the much smaller variations where we measure the storm time changes, the substorms, the sudden commencements, even pulsations we are able to see in the geomagnetic data. So with the network, we are able to see how all these changes happen on the field at various locations of the Earth, and that's how we are able to understand what are the mechanisms which are working right from the core, which drive the secular changes, to magnetospheric and ionospheric processes which control the smaller time changes of the field, for example, the storms and recovery periods, the solar cycle effects. These are coming from the external variations. Concentration of magnetic materials in the crust also produce a local or a regional kind of magnetic field changes. These changes happen over space. These are spatial changes of the field, and very commonly they are measured by using a total field scalar magnetometer, either through surveys on the ground. So people will take magnetometers and measure every few regular distances on the ground, or by ship, and also by airborne methods. Same magnetometers in different platforms measure the changes, and we have crustal level variations of the magnetic field in most parts of the world now. Geomagnetic studies also include measurements of both the electrical and the magnetic components of the field, which can be later interpreted in terms of conductivity changes which are happening in the crust, in the metal, and even deeper. These measurements are based on the principle of induction, because the moving or changing magnetic field induces a current in the conductive material on the ground, and the electrical measurements pick that up, and it is possible to now interpret those changes in terms of the conductivity of the material which generated the electric field. Measurements of the geomagnetic field is more and more increasingly being done from satellites. The earliest such satellites were initiated by Russian satellite Sputnik, and later by MaxSat, and now there have been a series of satellites measuring the changes of the magnetic field of the Earth. Till right now we have a constellation of 3 satellites. They are called Swarm A, B, and C, which cover the entire Earth in different directions, and keep measuring the changes of the magnetic field on a continuous basis. Satellite magnetic measurements have brought very important and very new information about the changes of the magnetic field, especially at ionospheric and magnetospheric levels. We have been able to see a lot of new variations which perhaps would have been more difficult to measure from ground observatory data alone. However, the two are very complementary data. The satellite measures on a continuous mode For example, when ground observatories are not available over the oceans, we still have satellite data over all the oceans, and so the coverage is extremely good. But at the same time, since it's a moving platform, we need the ground observatories to be able to measure continuously the changes in the field, even when there are gaps in the satellite data, because there may be gaps in between missions. So the two together give us the information about the entire spectrum, except perhaps of the very old changes of the field and reversals. But all the other spectrum are measured together, and the data are modeled and interpreted together, and they give us a new understanding of the field and its changes and the mechanisms which drive them.